Ladies and gentlemen, dear participants, welcome back to Stage Bob here at our Quantum Summit. In the next 1.5 hours, we will have a closer look at quantum sensing and other quantum technologies in this section. So our first speaker here will be Nicholas Spethmann. Nicholas Spethmann is once again a physicist, so we are back to our physicist section, so to say. He obtained his PhD in 2012. He got a Marie Curie Fellowship at Berkeley, and in 2017 he joined PTB. PTB, for those not familiar with it, is the German National Metrology Institute, where since 2019 he heads the Quantum Technology Competence Center that he will explain to us in more detail now, and what PTB is working on here in terms of quantum technologies. Welcome, Nicholas. We're looking forward to your talk. Feel free to start. Thank you.
Yeah, thank you very much for the nice introduction, Roman. I hope you can all hear me and see my slides.
Yes, we can hear you and see your slides.
Yeah, so hello to everyone. I would like to introduce to you the Quantum Technology Competence Center, QTZ, at PTB, as Roman just pointed out. Let me first start with saying a few words about PTB. Since that maybe is not familiar to everyone in the audience. So PTB is Germany's National Metrology Institute, and that means PTB is responsible for providing the national measurement infrastructure and in Germany on an international and competitive level. So you could also say we are responsible for realizing and defining in Germany what a meter is, what a second is, what a kilogram is, and what a volt is, and so on. So now you might wonder, what does that have to do with quantum technology? And it turns out it actually has a lot to do with it. And for this, I just wrote down here, since 2019, we now have a new definition of the fundamental SI units. And since then, almost all the units are based on natural constants. And since we all know quantum mechanics, quantum physics is very fundamental to nature, that means if you realize those units, you usually use experiments, machines, apparatuses from quantum physics, which is to say you use quantum technology, basically. And that's basically what I want to show here on this slide. That basically means that quantum technology is rooted very deeply in PTB, and we have several quantum technology fields under one roof. Let me just briefly mention the main fields here. So one that's very well known certainly is atomic clocks, optical resonators, and also frequency dissemination and sensing and metrology. Another one is ion traps for quantum computing and simulation. The large field of electrical quantum metrology for defining the volt and the ampere, for instance, which is also related to superconducting quantum computer technology. And then we have magnetometry using, again, superconducting technology and also optical technologies. And then finally, another large field is what's called here something like single photon physics, of course, metrology and sensing using single photon sources and detectors. And that's relevant, obviously, for quantum communication applications. So already here you can see that we have connections to basically all the pillars that are sometimes defined in quantum technology, from quantum communication over sensing and metrology, over to quantum computing. And what's special at PTB is that we have all this under one roof. We have permanent structure to perform research in all those fields. And in many cases, the expertise and infrastructure we have here is on a world leading level. So what does that all have to do with, well, this conference and the use of quantum technologies for economy? This is exactly where the new Quantum Technology Competence Center comes into play. The basic idea is to use all this infrastructure and expertise and to help to develop this into commercial applications together with partners from industry. I think on this summit, we also heard many talks that one of the challenges is actually the interface between research on one hand and industry on the other hand. And this is exactly where the QTZ is operating at the interface between industry and research. Okay, just to give you a flavor of the general aspects of the QTZ, I just want to show you this slide here. To just summarize what I tried to motivate up to here is that the QTZ works as PTB's hub for access to the quantum technology expertise and infrastructure, especially for partners from industry. And I should say, of course, the focus at PTB is quantum metrology and sensing, and it's also hardware. So we are very much focused on hardware, so we can't offer much or anything in terms of software, which of course is also important, but that's not our expertise. And the idea again is to support the development of quantum technologies with economic potential. But it's important to say that we are not a company. We are part of the Ministry of Economics and Energy in Germany, which means we don't want to and we can't create products. But what we can do is we can help partners from Germany and Europe to use our expertise and infrastructure to develop actual products. So what do we think are the main challenges when you do something like this? And that's shown here, the fields of activity that we try to address in a more effective way in our competence center. And one aspect that's very important from our point of view is robust and user-friendly components and technology. And I think that's also something we heard on this summit. Germany is excellent, well, some would say at least, is excellent in research, in fundamental research in quantum physics and also in quantum technology. But that's not what you need if you want to commercialize products. You need something that can actually work on an industry floor or in the field, basically. And for this, you need components and technology that is robust and user-friendly. So that's one thing where, in cooperation with partners, we work on. And I will show examples for this. Another very important aspect from our point of view is something we call here, well, independent calibration and services. You could also say certification up to standardization. And here, from our point of view, the challenge is that once you have quantum technology products, there will be components in those products. And those components need to have data sheets and specifications. And those need to be measured and certified by someone. So you need someone who can independently measure those. And that's, of course, we as the National Metrology Institute, where we look into this direction, doing this for quantum technologies. Another thing that's new for PTB in this quality is something we call user facilities. And I think we also heard about this on this summit already, that quantum technologies is a bit special because it's nothing you can easily start. So for one, you need complex, expensive, and also sometimes large apparatuses and laboratories. And it's not easy just to jumpstart into such a field. So you need to try out maybe your idea beforehand. That's one of the ideas for those user facilities. So what we do here, and you can see down here the different user facilities that are currently being set up at PTB. So what we try here is to give people, external partners, access to quantum technology demonstrators that are not research grade in the sense that they are on the very high top level, but still very good. But they can be used like more hands-on to try your own ideas, to figure out if quantum actually helps you for your application. That's also something that's not obvious always. Just to give you an example, for instance, if you think about quantum communication, you need to figure out what you need to control on your single photon communication line, for instance. And then sensing and metrology single photons is extremely important. And also to understand how well you can do that actually. Another example would be magnetic field sensing. If you want to build very good sensors and you have maybe a classical product and a quantum product, let's put it like this, and you want to benchmark them, then you can also work with us and figure out what the benefits actually are. Okay, so that's those three fields of activity. Another one that's also very important for us is something that's called here hands-on training. You could also say quantum education. And I think in the parallel room, there's a lot of discussions going on exactly on this topic right now. That's also something that's very important for us, and this connects to the expertise we have at PTB. So we think that if you actually want to get quantum technology into industry, you also need to transfer the expertise. And I won't say much more to this because of time constraints, but if you're interested, I'm happy to discuss afterwards about this. Okay, I just want to briefly mention, and I'm sorry this is in German because this is a German Regierungsprogramm. The initiative of QTZ goes back basically to the Regierungsprogramm from 2018, and I'm mentioning this because we heard about it yesterday, I think in one of the opening talks. I just want to say this is also part, basically, in that sense, of the Regierungsprogramm. Okay, so this was really the general idea and picture that we are working on at PTB. So what does that all mean, and where does it actually come down to an application and to an example at hand? And for this, I just want to pick one example and guide you through a few slides where I try to give you a little bit more of a flavor of what we actually are doing. Okay, so why ion traps? Well, ion traps are a key technology in QT. For one, for atomic clocks, something that's very close for us, obviously, and also something that also has very great opportunity for applications, for instance, relativistic geodesy, and also, well, timing applications that are basically used for navigation. For this, you, of course, can use always better frequency metrology. So that's one technology that's enabled by ion traps. Another technology is quantum computers and quantum simulation. And in both fields, we have connections. And on the right-hand side, what you see here is examples of ion traps that have been designed, fabricated, and also used, put to use at PTB. And two of those, these guys here, are used for frequency metrology or atomic clocks. And this guy here is used for quantum computing. So we basically have examples for both. Okay, so in the light of what I said before, what does it mean now if I talk about certification and user facilities and stuff like that? Okay, in this case, it means we are building a machine and demonstrator that allows automated and a reliable test facility for ion traps. And that's because in many cases, ion traps are really research devices. You build a few, put them into a research device and use them for years. That's fine for research. That doesn't work very nicely if you want to go to industry production. Then you need a closed short cycle where you can actually develop and test out what you're doing with your ion traps. And that's exactly what we're working on. As far as I know, something like this does not actually exist. I don't know that it exists anywhere, maybe in a very few places on Earth. But that's what you need if you want to commercialize this. Another important aspect that we also tackle with the same, well, user facility or apparatus, if you like, is that in this way, we also have a way to get to a independent characterization of ion traps using our expertise in this field. Okay, just to give you a flavor of how this looks like, here's a photograph from the user facility. So, okay, you have the usual, you have optics, which are to some degree at least higher integrated than usual. You have the heart of the machine where you can put your ion traps into, and then you have automated control. I don't want to go into detail, just to give you a flavor here. Okay, that's all nice. Of course, you could argue PTB, of course, likes to characterize quantum technologies. That's nice, but who cares? Do you actually need this? Where's the application? And for this, I brought two examples from our from the past or current activities at PTB. And those are, again, from the two fields I mentioned before. So on the one hand, you have the so-called optical project, which is an atomic clock, so a sensing device, which has an ion trap in here somewhere. And the idea here was, in a consortium of industry and academia partners, to basically take what you usually have in an optical quantum optics lab using an atomic clock, put this into a more robust and user-friendly fashion, at least into some racks that you could think of using as a transportable clock. So that's one example. And I should mention this clock is supposed to replace, for instance, other frequency metrology devices, and offers a increase in precision than anything you could buy at this point. Okay, on the other hand, we have the quantum computer application. So again, here's a photograph of a ion trap from PTB, where you can basically see in this small picture here two charged atoms, so ion singly charged atoms hovering across the surface of this atom chip. And the same control that we use to build atomic clocks, you can now put to use to build a quantum computer on this platform. And this is exactly what's happening in Quantum Valley, Lower Saxony, where PTB is partner in this consortium of people, where the goal is to build a 50-qubit quantum computer within the next 5 years using this technology. Now the question is, what do you need to do to achieve this? And this is shown in this schematic here. So what we need is we need to integrate all the things that we have in a laboratory surrounding the ion trap onto the chip. And that's what you see sketched here. So optics, electronics, sources, all on a chip. And then we need to scale this up to get to a situation that you can actually use this with many qubits. And that's something, again, that we heard in other applications as well on this summit. Okay, with that, I think I just gave you like 2 examples from one field, basically, of QTZ. With this, I just want to widen the view for the remaining 2 minutes and address this point of calibration and services and standardization very briefly. So I already mentioned that if you want independent characterization and certification, you need the metrology. That's what we work on. But you also need standardization and standards that you can use such that you get a comparable and reliable characterization of your QT components. Something like this exists in a few single fields, but not generally in many fields. It's simply not existent. That's the reason why last year in an initiative from the Quantum Flagship and others, Sensenelec set out to found the so-called focus group on quantum technologies, where the idea is to first off figure out what we need to standardize to get to a situation that we can actually commercialize QT. And the goal is here to have a standardization roadmap for QT. You see just a few key figures here. From my point of view, what's also important here is that people from all over Europe that are active in this field, from science, industry, and standardization, come together here and just talk and understand their respective viewpoint, which is a very important development from my point of view. So that's going on, and I'm happy to be one of the chairs of this focus group. I just want to mention, if you are interested in this, or you are from industry and you think about this, we are always looking for more participation. Feel free to contact me. I'm happy to discuss. Okay, so with that, I would actually stop where I started, and thank you for your attention. And again, if you're interested, please feel free to contact me. Thanks.
Thank you so much, Nicholas. That was enlightening to see the broad range that PTB is covering here in terms of quantum technology hardware, as you have pointed out, which has always been naturally the strong field for PTB. We have 2 questions from the audience. The first is, as you may develop already schemes for certification of quantum technology hardware components, when do you expect a catalog or labeling being in place? And will this focus on Europe or worldwide?
Okay, so that's several questions, I would say. Of course, we are already busy doing certification, also in some fields of quantum technologies. So one example would be single photon detectors, I guess. So if you want more details, feel free to contact me. The other question was, is this Germany, Europe, or worldwide? That's, of course, an important question. As you have seen, this focus group is already on a European level. And we as PTB think that it does not make sense to focus too much. And certainly partners from all over Europe are very welcome to cooperate with us and also beyond. For the standardization aspect, of course, it's important to make the connection to worldwide standardization efforts. And we are doing this also in the focus group at Sensenelec.
Thank you. There's one more question. What are your thoughts of integrated photonics for ion traps? What are the plans at the PTB regarding PICs?
Yeah, okay. I think that's a very, it's a great question, and that's actually very interesting for us. I think this is where we try to go. And this is not PTB on its own, but it's embedded into our cooperation partners. For instance, in the Excellence Cluster Quantum Frontiers, I mentioned QVLS. So the universities, we are working together there. That's actually an active field of research. And if you want to know more, again, feel free to contact me.